This is a video for learning map I've done for generating electricity, and it comes up in P1 part 2 AQA. So when it comes to generating electricity, we have different methods that we can use. We have renewable and we have non-renewable, okay? So renewable doesn't run out, it's a resource we can use continually, whereas non-renewable, it can only be used once and there's a limited supply of it, okay? So I'm going to go through the non-renewable first. So we have coal, oil, natural gas. They're the fossil fuels, okay? Now, oil isn't generally used on a massive scale. You might have a little petrol generator that people use themselves, but it's not a massive scale thing. We'd rather use our oil for things like petrol and diesel for our cars. So fossil fuels, they can ask you how it is produced and the energy that is involved with this. So the production for fossil fuels is they will burn the fuel, so the coal and natural gas. That's chemical energy. That's then used to heat water to steam, really high pressure steam, which would be thermal energy. That steam is then piped to turn turbines, which is kinetic energy. And then those turbines will then turn a generator, which generates electricity, which is electrical energy. These are called thermal power stations. Now, you then need to be able to evaluate the advantages and disadvantages of these. So advantages would be it produces large amounts of electricity. We know how much it's going to produce, so that's a really advantage for us. Easy to find and transport. We know where oil is, we know where coal is, it's not hard to transport it to the locations either. And you can generally build power stations quite easily, although people might neglect, say they don't want them near their homes, but you can generally build it quite easy. Disadvantages, though, are it produces carbon dioxide. Now the problem with this is it's a greenhouse gas, which leads to the greenhouse effect, which means that it gets warmer, which leads to global warming, okay? Massive points there, it comes up so many times. Another disadvantage, it's a non-renewable resource, we will run out, and also it's depleting natural resources that we have. How can we reduce the amount of CO2 level? I've seen this come up before, and it's not necessarily planting trees, it's something called carbon capture and storage, CCS for short. So what you do is before you release the gases out the flue from the power station, you catch the gaseous carbon dioxide and you'd liquefy it. When you've liquefied it, you can transport it to locations of depleted oil or gas fields, and you can pipe it down into it, and that's usually got an impermeable layer of rock above it so it won't get back out again, and then over time it'll just dissolve as carbonates into the rock. So that's one way we are looking at. Nuclear, believe it or not, is actually non-renewable. A lot of people get confused by this. It's not going to run out for thousands of years, but it will run out, so it is non-renewable. You don't need to know it in too much detail because it comes up more in P2, but the way this works is they use uranium or plutonium and it undergoes nuclear fission, which is nuclear energy. That is then used, it gives off a lot of heat. The heat is used to heat water into steam, so thermal energy. That steam is then used to turn a turbine kinetic, and then that turbine turns a generator electrical. It is also a thermal power station, okay? Advantages of this is you get huge amounts of electricity for 1 kilogram of fuel. Comparing coal to nuclear, it's just you get so much more from nuclear. You don't produce carbon dioxide, okay? Don't say it produces less. It doesn't produce any at all. So that's not leading to global warming. It's not contributing to it. It's readily available and it won't run out for thousands of years. So that's quite a good thing. Negatives, though, are it does produce highly radioactive nuclear waste that we then have to store underground in different locations. So that's a bit hard. It costs quite a bit to make them and to decommission them, so take them down. And then there's a very slow start-up time. It takes about several days to actually start a nuclear power station up. And then, of course, you have a risk of an accident going wrong. We had Chernobyl 30 years ago, and then we had Fukushima 5 years ago. So there are those risks that could happen. Renewable energy then, you have solar. Now, you don't need to know necessarily how it works, but how it does work is sunlight goes onto, it's a semiconductor inside the solar cell. That excites the electrons, they start to flow basically. So you have sunlight, which is light energy. Then that will get changed into a direct current, which is electrical energy. Advantages are minimal maintenance is actually needed for them. You can use them in remote locations, so they don't need to be connected to a grid or anything. Doesn't produce any carbon dioxide, and it is renewable. Disadvantages are, per solar cell, you get quite small amounts of electricity. You need quite a few to make anything worthwhile. less or no electricity when it's cloudy at night time, okay? Don't say because there's no sun there's always a sun. You mean there's no sunlight, okay? Wind energy, okay, these wind turbines that cost thousands and thousands of pounds, they cost quite a bit as well. So wind energy is kinetic energy. That will then turn the turbines, which is also kinetic energy, which then turns the generator inside the shaft, which is electrical energy. Advantages are it's renewable, no carbon dioxide. Disadvantages are spoil the landscape, they're quite noisy. And I don't know if you know this, they can only be used under certain wind conditions. When it's too windy, you have to actually turn them off. And the farmers who have them, you actually have to pay them to turn them off. So it's a little bit of a counterproductive thing with regards to cost. Hydroelectric came up last year and they do like to talk about it. So this is when you dam a river or a naturally flowing body of water. So when it's held up high, it has gravitational potential energy. When you release the water, it then has kinetic energy because it's moving. That water then turns a turbine, also kinetic energy, and then the turbine turns a generator, it's electrical. It is instantaneous. This electricity happens pretty much as soon as that water's hitting the turbine and turning the generator. Advantages are it's renewable, no carbon dioxide, no fuels needed, very, very quick start-up time. And disadvantages are it kind of changes the environment and disrupts natural looking habitats and stuff, so that's quite disadvantage. This is what we use when the national grid needs to quickly get energy. So for example, at the end of Strictly Come Dancing or the end of the X Factor, everyone goes and put the kettle on. If you're my age, you go and want a nice cup of tea, and kettles use quite a bit of energy, like we're talking 3 kilowatts. So if everyone in the country is drawing that amount of energy at the same time, you need that next bit of demand, okay? So they use that for peaks in demand. Tidal and wave doesn't come up much because it is kind of like a new one that we're using, but it can be mentioned. You can get things called tidal turbines or a tidal barrage. A tidal barrage is a little bit like a hydroelectric one, works on the same principle. It's renewable, no carbon dioxide. Disadvantages are not many places that you can actually use it or build it, and the tides at different times, it changes according to the moon. So if it's at night time, you don't really need electricity at night time because everyone's asleep, so it's a bit of a not really useful. Another one could be biofuels, sometimes called biomass. When you burn a biomass, you get a biofuel because anything you burn then becomes a fuel. So with this, it's things like wood, sunflower oil, vegetable oil, methane from cow poo, it happens. And what you do is you burn that, and that's a form of chemical energy. And then you use that heat to heat water to this high pressure steam, which is thermal. Steam turns turbine kinetic, turbine turns generator electrical, okay? This is also a thermal power station. Advantages are it uses waste products, so lowers the cost. So because you don't really need cow poo for anything apart from manure. So if you use the methane gas fermented from that, it's very low cost basically. It can then supply local homes because you can build them anywhere really. Now this word carbon neutral is an advantage and should only be used for biofuel. Basically means that when these plants were alive, they took carbon dioxide out the atmosphere maybe a year ago, maybe 2 weeks ago. And it's only going to release the same amount of carbon dioxide that it took out as regards to these, which took it out millions of years ago. Okay? The disadvantages might be that it releases carbon dioxide. So it does still do it, even though it's carbon neutral, it still releases carbon dioxide. You can grow biofuels instead of food crops. And what I mean by this is farmers will actually get paid more money to grow biofuel than food. So, of course, businessmen are going to go, I'm going to grow biofuel. Well, that leaves us in a deficit of farmland to be able to grow food. So then you have to cut down rainforests for extra farmland. So that's quite a problem. And the ones that you can build little power stations are visual pollution, basically. Geothermal energy is basically energy from hot rocks. It's in countries that have high volcanic activity. So basically, under the rocks, you can have little streams that will turn to steam. You can then burrow a hole, pipe the steam directly to a turbine. So the steam, which is thermal energy, will be collected and then used to turn a turbine, which is kinetic, and then the turbine will then turn a generator, which is electrical. Advantages will be it can be used to heat local homes, it's renewable and no CO2 is produced. Disadvantages will be it cannot be used everywhere, so we couldn't do it in this country because we're not volcanic. Next one is national grid. Now that has not come up for a couple of years. And I did see them ask a few years ago about what the national grid actually is. It was a tick box exercise, and loads of people got it wrong. It's actually a system of cables and transformers, not the power stations. Don't include the power stations. So when you get electricity generated from a power station, be it any of these, it will go to the national grid. Now, when it will go to a step-up transformer. Now, that will increase the voltage, and by doing that, because P equals I times V, it would decrease the current. We do this so it's more efficient because the current is what has the energy. So if it's high current, you get high heat transfer, which would make it less efficient. So it then goes along high voltage pylons to a step down transformer. Now this will decrease the voltage and then increase the current. To factories, to 1 voltage, and then to homes, it will then do it to 230 volts, decrease the voltage further and increase the current. Another thing they can relate it to is startup time, okay? So how they get their base load of electricity and how they get these peaks. So this is startup time. So hydroelectric's really quick, then you've got natural gas is really quick. Coal, you're talking a few days, and then nuclear is about several days. So they can say, what would you use for your base load? Will that be coal and nuclear? And then what could you use when you need a peak in demand? That would be hydroelectric and natural gas. Thank you.